Hi guys, since I am not in today, I thought I would still just do a couple of the assignment questions with you. I'm just going to skip around and do like one or two in each section. So first, I'm going to do letter D. So you're finding the area under the curve. So this is the whole thing. So from -4 to 5. So when we are going in the right direction, everything above the x-axis will be positive area, and then underneath x-axis is negative area. So this triangle right here would be 1/2 times 2 times 3. So that is 3. And then I'll subtract the area of this circle, semicircle. So that's radius 1, so pi r squared, but then cut it in half. So we're going to subtract pi over 2. And then for this trapezoid, we have the 1/2 and the height, and then adding the bases, we should get 9. So this is 12 minus pi over 2. I'll do one more in this section, and that will be E. So going from 4 to 2. So from 4 to 2 is moving left. So even though this is above the x-axis, because we're going left from 4 to 2, it's actually negative. So instead of a +6, this is a -6. So these are all pretty easy. You just have to kind of look for these other operations and apply those properties. Okay, so first it says sketch a graph. So we're going to sketch a graph of this function. That's the square root function that's shifted left 1 and then also reflected on the x-axis. So it's going to look like this. And then the area from 0 to 3. So this is the area that we're going to find. But we're actually going to use our graphing calculator to do this. And this is just hitting the Math 9 button. We've been doing Math 8 for derivatives, and now we can hit Math 9 for the integrals. And I think you should be able to figure it out. This one, just to check that you're doing it correctly, it should be -4.666. Okay, in this section, so you're given these 3 integrals. They have solutions, and then you're just using the properties. So let's do number 7. So it's f of x, so notice how 2 of them are f of x, and then this one is g of x. And it's saying from -3 to 7. Well, if -3 to 2 and then 2 to 7, well then from -3 to 7, we can just add these. So it's just 2 plus -5 for your answer. And then number 11, so let's see, we have a negative in front, but then notice how these are backwards. So instead of 2 to 7, it's 7 to 2, so it's like a negative of a negative, oh, and then it is -5. So this would make it go to +5, but then it goes back to -5. Okay, so here I'm going to help you set up the problems and then have you guys finish them. So here we have this f of t, and then we have this accumulation function g of x. So find the average rate of change of g. So let's just think about how you always do average rate of change. So it's from -4 to 6. So let's say g of 6 minus g of -4 over 6 minus -4. So how do you do g of 6? Okay, so g of 6 is the accumulation of that function from 2 to 6. So g of 6, we are finding the area from 2 to 6. So here looks like -2, and then here is a positive 1.5. So then g of 6 is going to equal negative 0.5. So you're just kind of completing that to find the average rate of change. Okay, instantaneous rate of change with respect to x, so of g. So that just means take the derivative. So if you're taking the derivative of an integral of an accumulation function, think about what you would do. So the derivative is just f of x, and then plug in 5. So what is f of 5? Well, this is your f function. So f of 5 is just the y value. It's just 1. Okay, the next two questions is going back to that unit 5 stuff. So when is g concave down? And then when does g have these local minimum, maximum? So the g function, you always start by taking the derivative. Well, here's the derivative of the g function, which is this. So when is it concave down? Well, that's when the second derivative is negative, or where the first derivative is decreasing. So you can find that. And then think about your minimum and maximum. It's when the first derivative, a minimum is when you're changing from negative to positive, and a maximum is when you're changing from positive to negative. So go ahead and find those. Good luck with everything today. And if you have any questions, we'll go over it tomorrow.